By completing this lesson, you will improve your ability to use baseline and trend measurements to monitor the condition of your electrical and mechanical systems. Every architect and builder knows that when designing a structure, you need to establish a solid foundation. Similarly, a baseline measurement establishes a foundation that all subsequent measurements are based on. The first step is to capture baseline measurements when the motor drive system and associated systems are operating correctly in a known good steady state. Some measurement captures will be numeric, others will be waveform images, thermal images, or vibration readings. Next, compare the current state to the baseline data, while capturing additional data to identify trends. If change in any one parameter is greater than 10%, increase the frequency of inspection. If values continue to change, ensure that there is no outside factor driving the change, such as warm-up or cool-down, and correlate with additional measurement equipment types, adopting a troubleshooting methodology. A DMM is a fundamental tool used to capture voltage, current, and resistance readings. It can be supplemented with the use of an AC current clamp accessory to measure the overload current with the motor operating at 80% load or better. When making the measurements, always wear the appropriate PPE for the environment. Establish a baseline measurement on all motors in the plant by measuring the overload current and voltage on all phases. This will extend motor and drive life cycles, help you anticipate motor failure, and properly size motors for the load. Drag the device and its clamps to the correct location to measure three-phase overload current on the system. Incorrect locations will bounce. That's correct. "27% of all motor failures are related to winding insulation breakdown. An insulation resistance tester supplies non-destructive DC voltages to the windings and insulation points of a motor to measure the current leakage rate. The current leakage rate on motor windings gradually increases until the point of insulation failure, at which point a short circuit to ground occurs. There is no perfect insulator. They all leak. But the question is, how much do they leak, and is the insulation leak rate changing through time due to insulation breakdown or contamination? Once a short to ground is detected, a catastrophic failure of the device has occurred, and it is too late for preventive maintenance or proactive remedies. Perform an insulation spot test at regular intervals, typically every 6 months, to track the changes in insulation integrity over the life of a motor or a critical piece of equipment. Always disconnect all power from the motor or component under test by using appropriate lockout/tagout procedures, and follow the motor manufacturer's instructions for measuring the insulation breakdown on the rotor and field windings. Do you remember the parameters for measuring insulation resistance? Click the correct answers in the table below. That's correct. Technicians can quickly measure and compare heat signatures for each piece of equipment on the inspection route, without disrupting operations. If the temperature is markedly different from previous readings, use other maintenance technologies such as vibration, motor circuit analysis, airborne ultrasound, and lube analysis to investigate the source of the problem and determine the next course of action. A thermal imager is a great tool for spot checks to see if motors and associated panels and controls are operating too hot, and for troubleshooting to track down the specific failed component at fault. It can also check for phase unbalance, bad connections, and abnormal heating on the electrical supply. If a temperature reading in the middle of a motor housing comes up abnormally high, take a thermal image of the motor and find out more precisely where the high temperature is coming from: windings, bearings, or coupling. If a coupling is running warm, it is likely an indicator of misalignment. Fluke includes powerful software that makes it easy to optimize images, perform advanced analytics, generate quick, customizable reports, and export images to the format of your choice. Start with a newly commissioned and freshly lubricated motor and take a snapshot of the motor bearing housing while the motor is running. Use this image as a baseline. As the motor and its lubrication ages, the bearings become worn, and heat-producing friction develops in the motor bearing, causing the outside of the bearing housing to heat up. Take additional thermal images at regular intervals, comparing them to the baseline to analyze the motor's condition. When the thermal images indicate an overheating bearing, generate a maintenance order to replace or lubricate the bearing housing and reduce or eliminate the possibility of costly motor failure. Looking at the number alone for the overall vibration or bearing condition might not be of much benefit if you don't know what is normal or what indicates a problem. With the Fluke 805 vibration meter, you can use the severity assessment and trending functionality to overcome this obstacle. After measurements are taken during the rounds, results can be easily uploaded into Excel. From there, you can trend with pre-configured Excel templates and plot graphs and compare the overall vibration readings to ISO standards 10616-1 and 7. If there is an abnormality, it can be identified by using the trend charts. This enables you to see a clear picture of the changing bearing condition and deteriorating health of the machine. Drag the vibration meter to the location to measure the baseline with crest factor, overall vibration, and temperature. Incorrect locations will bounce. That's correct.
That's correct.
Quickly locate and diagnose common mechanical problems using the Fluke 810 vibration tester. Run a route through the facility to analyze common equipment like motors, fans, and pumps. This will help you determine the root cause and location of mechanical failure, and will give you immediate fault severity during the equipment assessment, providing repair recommendations. By establishing a baseline and understanding of machinery health, you will be able to anticipate problems before shutdown. Remember, 68% of technicians use vibration as the best way to perform predictive maintenance testing on motors. 51% of all motor failures are caused by bearing failures, primarily with incorrect, insufficient, and/or excessive lubricant. What does the readout from the Fluke 810 vibration tester indicate? Click the correct answer. Incorrect answers will be marked with a red X, while the correct answer will be marked with a green check mark. That's correct. The The readout indicates that the motor shaft is the source of the problem. Misaligned machines cause higher reaction forces in the coupling, which leads to heat and wear in couplings, seals, and bearings. These worn components cause increases in unplanned downtime, energy consumption, and unnecessary maintenance intervals. Regular precision alignment reduces mechanical seal repairs by up to 65%, and when precision alignment becomes an integral part of pump repair schedules, the rate of pump repairs is reduced by up to 30%. Power quality analyzers should be used at a safe location, typically installed at the PCC, point of common coupling. This is where the utility connects to your facility, downstream of the main disconnect and installed following all safe work practices. Monitor over time to discover the state of health of your power system, and measure electrical power parameters such as voltage, current, power, apparent power, power factor, harmonic distortion, and unbalance to identify characteristics that impact motor efficiency. Once a fault is detected, the monitoring can then take place on branch circuits to drill down to root cause. Click the link to view additional troubleshooting tips for power quality problems. Here are 6 troubleshooting tips for power quality problems. When you're finished reviewing, click the X to return to the previous screen. True or false? The readout from the Fluke Power Quality Analyzer indicates a problem. Click the correct answer. An incorrect answer will show a red X. That's correct. Voltage unbalance greater than 2% is potentially problematic, and current unbalance greater than 6% is potentially problematic. An oscilloscope is used on the output side of the drive to detect out-of-tolerance power, harmonic distortion, and unbalance conditions. It's also used to record and analyze inrush current, the initial surge of current drawn by a circuit when voltage is first applied. Each motor has unique starting characteristics that must be taken into consideration when analyzing inrush current. Not only the internal motor design, but also external factors, such as voltage amplitude, ambient temperature, and load, affect inrush current. All these factors should be recorded and considered when trending or analyzing a motor over time. Trending the DC bus voltage is useful to identify pending malfunctions. A DC voltage value that is too low can cause the drive to trip. At the cause, the mains input voltage is probably too low, or the input sine wave might be distorted by flat topping. If the ripple's peaks have a different repetitive level, one of the rectifier diodes is possibly malfunctioning. This is load dependent. Ripple voltages above 40 volts can be caused by malfunctioning capacitors or a drive rating that is too small for the connected motor and load. The DC bus voltage is approximately 1.414 times the RMS line voltage. For example, for a 480 volt AC drive, the DC bus should be approximately 678 volts DC. Drag the oscilloscope to the location to measure the various baselines. Incorrect locations will bounce. That's correct. In any electrical installation, some current will flow through the protective ground conductor to ground, usually referred to as leakage current. Leakage current most commonly flows in the insulation surrounding conductors and in the filters protecting electronic equipment. On circuits protected by GFCIs, ground fault current interrupters, leakage current can cause unnecessary and intermittent tripping. In extreme cases, it can cause a rise in voltage on accessible conductive parts. Ultrasound will allow you to monitor the amplitude and sound quality on similar bearings, to hear the friction and stress in rotational machinery, triggering a need to lubricate or replace the bearing. By monitoring the friction levels of bearings with ultrasound, you can determine when the lubricant has deteriorated and needs replacement. But remember, over-lubricating could be just as harmful as under-lubricating. By listening as you apply lubrication, you will use the correct amount. Trending against an established decibel level, increased friction levels are quickly spotted and alarms are triggered. Oil analysis is a quick, non-destructive way to gauge the health of an engine by looking at the contaminants suspended in the oil. When you do an oil analysis, try to draw the sample with minimal disturbance so as to eliminate any outside contamination, and use a small clean bottle that can be sent to a laboratory for analysis. Studies show that organizations spend 80% of their time reacting to issues rather than proactively preventing them using predictive maintenance, PDM, software. PDM allows you to predict failures and monitor performance on your most critical assets, allowing you to define acceptable boundaries for equipment operation, import readings, graph results, and automatically trigger an email or generate a work order when boundaries are exceeded. The empirical data provided can help improve asset reliability and boost cost efficiency. CMMS software plays a key role in asset-based data collection and analysis. People use it to providing a detailed list of all plant assets including electrical, process, mechanical, thermal, and oil analysis. Keep assets functioning, including ensuring equipment availability, boosting production, driving product quality and extending the asset life cycle. Manage people and processes, including getting organized, scheduling the I&E team, increasing worker productivity, reporting to management, and managing vendors and suppliers. Maintain a safe and compliant workplace, including establishing procedures, managing and tracking incidents, verifying and tracking compliance, and managing documents and permits. And control costs, including containing and reducing maintenance cost, reducing parts and spares, and managing warranty cost. Connect assets enables maintenance managers to visualize multiple measurements, including mechanical, electrical, and thermal, organized by piece of equipment. A solution that is designed for easy installation and setup without involving your IT team. Fluke-connected tools allow wireless measurement transfer of baseline, historical, and current inspection data, all stored in one place. And because this is a wireless measurement transfer, errors are reduced, eliminating mundane data collection so the maintenance team can focus on the real work. View status overviews through multiple dashboards without being in front of the equipment. Monitoring plant equipment is crucial to avoiding costly downtime, but it is often too expensive, impractical, or complicated to capture performance data from all critical assets. In many cases, critical assets have built-in sensors that provide early indications of problems that need to be addressed. But what about pumps, heat exchangers, compressors, and blowers? Assets that are also important to your operation, but don't have automated monitoring sensors to indicate a potential problem. Fluke Condition Monitoring solves these problems with a new system of rugged voltage, amps, temperature, and power sensors that can be moved from asset to asset and left in place for over 4 weeks, continuously collecting and streaming valuable information that can be accessed from a mobile device or computer. Without